In this video, we're going to look at how sediment becomes a clastic rock. So diagenesis is a really big term for all the physical, chemical, and biological processes that transform sediment into sedimentary rock and that alter the characteristics of that sedimentary rock after the rock is formed. So this includes these steps we're about to talk about, as well as weathering, like dissolution of limestone that we talked about in the last class. So lithification is the process by which we turn sediment into rock. And so the difference between these is one's glued together and one is not, basically. All right, there's two main processes that create, that allow for lithification. One of them is compaction. In compaction, all of the air pockets and water pockets are forced out of the sediment. So just plain old mud has air and water and all sorts of stuff in it. But if you squeeze and compact it, and in this case there's got to be pressure included in here, it's going to squeeze all that extra stuff out where all you have is a class left over. So that's one. We want to get rid of that extra space. But some rocks don't compact very much. So if you think about clasts like quartz and feldspars, right, so a weathered granite, these are pretty round clasts. So even after you compact it, it doesn't get rid of a whole lot of space there. So what we want to do is we want to somehow glue those grains together. And that is the cementation. So the cement is the stuff that glues those clasts together. And there's three common types of cements in sedimentary rocks. One is quartz, or one is calcite. So this is a thin section. So this is a sandstone. These big blobby gray crystals that are labeled Q, these are all quartz grains. All right. And in between those quartz big blobs is this kind of yellow light colored stuff. This is all calcite. So in this case, the calcite is gluing all of those little quartz grains together. Here's a couple more thin sections of sandstones. On the left, you can see this is even kind of a weird color, right? It's kind of pink. That's because it's iron oxide. This is hematite that are holding all of these together. This is going to make a really red quartzite. And on the right, these big blobs of quartz are held together by smaller blobs. So that's actually silica that's holding those together. So your three main types of cement are calcite, hematite, and silica. Let's think about those. Where does we get calcite and hematite and silica in nature? What processes create those? What about weathering? What weathering process would give us ions that could form calcite? Dissolution of limestone. What chemical weathering process would give us hematite? That's oxidation. And finally, one that gives us silica is hydrolysis. So this is sort of an interesting point here, because in order to get the pieces, the clasts that are going to make up a clastic rock, you have to have rocks be mechanically weathered to break them into smaller pieces. In order to get the ions that are going to act as the cement to glue those pieces together to form a rock, you have to have chemical weathering.